Hello, we want to talk about the high performance liquid chromatography here, or sometimes called high pressure liquid chromatography, and the abbreviated name of it is HPLC. HPLC. We want today to know the concentration of luteolin, which is one of the flavonoids in a herb, and we have a standard of luteolin as well. So we have mobile phase here, which is a mixture of water and methanol, and we have the stationary phase column. This is the column, HPLC column. It's full of silica or derivatized silica. Now it's called high pressure liquid chromatography because the mobile phase is pressurized by a pump, and we have the pump here, and we can see the pistons, the white rods, and they have a reciprocal movement as we see here. Yeah, and of course we have a detector to detect the components eluded from the chromatography. This is a UV detector, and we have the selected lambda here, 350, and the above number here is the absorbance. Okay, the instrument is equipped with a computer here. This computer to give the orders and the instructions of the chromatographic system, and we will start now by injection certain volume of the standard solution to know the retention time of the luteolin. Then we will inject and extract from the herb. Now we have a loop, and this is loop will take only 20 microliter. So any volume here above 20 microliter is okay, because the excess volume will be discarded automatically from the loop. Once we inject the sample here, we will wait. As we see here, we have two channels. We have 350, and we can see the chromatogram here. Okay, this is the chromatogram. And this is the 280 nanometer. So we can select one or two lambda, or sometimes more than two. Okay, if we focus on 350, because this is the lambda max of luteolin, this is the best lambda max of luteolin, we can see noises, but because we don't know the main peak, this is just noise with very little absorbance, as we see here, 0.00002. So we don't consider these as peaks because they have very little absorbance. See, now we have a new peak. See, now this new peak is a real peak, and all the noise now minimized, as we see here, and this is the peak of luteolin. Okay, or one of the luteolin degradants. We see now, we will leave it for a while to see if this is the luteolin or this is just byproduct of luteolin. Now the absorbance is still low, so we shall wait. At the other lambda we also see same peak. Now we have a new peak eluted. Is it significant or small? Is it small peak? Mhm. So these might be just byproducts of the Lithuanian standard. Now a new one is starting to grow up. This very strong one, yes, I will buy that. This is the Lithuanian, and if we see now the absorbance, yes, this is 0.6. This is a reasonable absorbance. And as we see that we have almost the same response at 2 lambda, 350 and 280, but 280 is less selective, so we don't usually prefer it for the test solution because we might see many components at this lambda. Okay, we will wait till 5 minutes finished. Here we have 4 minutes. As you see here that we have significant peak. We can take the area under the curve by just asking the computer to give us the area under the curve. Also the absorbance here give us an indication of the amount of the compound by comparing the test with solution. The test we don't have it now, we have just the standard solution. Now we can stop manually the runtime here. Now the computer is ready for another injection. Okay, so we will say that this is test solution. Now we ask our friend to inject a new injection from the test solution. This is the herb, and remember that the retention time is around 3 minutes here, as you see, for the Lithuanian. Okay. This is the loop of ejection. Now the instrument will take only 20 microliter from this volume, and the computer will start a new window for the test solution. We see the beginning of the noises here at 2 lambda, 280 and 350, and we have the noise here. But remember that our target is the peak, which has a retention time around 3 minutes. So we still far from 1 minute, 3 minutes. Just have a 1 minute rotation. You can see the noise. Now the noise might be a mechanical noise from the pump, or might be very minute impurities in the sample. So we usually don't give them any attention. We just waiting our main component, which is the Lithuanian, which should have a retention time of around 3 minutes. So we shall wait. We might have many components in the herbal extract, but we mainly looking for the component. We have a new component now. See, at 280 it has high